Hello, I'm Noah, and today I'll be discussing access control lists, or ACLs. We have a pretty simple setup here, but an ACL still serves as an effective security strategy here, especially for, in general, more less complex networks. So there are two types of ACLs. These are standard and extended ACLs. And in this example, I'll be using a standard ACL, which distinguishes network traffic by its source address as opposed to the destination. And because of this caveat, it should be placed in the interface closest to the destination. So for example here, to protect this 1.0 network, I set up the ACL on router 0's FA0/1 interface, permitting traffic outward and also denying unwanted traffic coming out of this interface. So say if this host, this 2.102 host, we wanted to permit, then it would come out through this interface if it passed the ACL. And the reason that we want to have it close to the destination is because this specific standard ACL is it's analyzing the incoming traffic. So if we had put it on FA0/0, then it's taking all the traffic that comes through here, and it would we don't want it to we don't want it to protect this 192.168.4.0 network. We're only trying to have it protect the 1.0 network. So if we have it here, then it's still in front of this network, and we might block things that we're not trying to block. And that's just overstepping the purpose of the access list, and that's not what we need to do. So for the specifics of this topology and configuration, we have static routes between these two routers, R0 and R1, connecting the 192.168.4.0 network with the 1.0 and 2.0 networks. And the ACL that we've set up here is meant to deny to the 1.0 network any communications from this 2.100 host or 2.101 host while allowing the 102 host. And then because the ACL is configured on the 0/1 interface, any of these hosts here trying to communicate with the 4.100 host should be successful because the ACL is not active on that interface. So to show that, we're going to go into our command prompt on these PCs, and we're going to show a ping from 192.168.2.100 to the 1.100 host, and we should get destination host unreachable, as you can see there, because the ACL is blocking this communication. But if we try to ping 4.100, then you're going to see that we can get through easily because the ACL is not blocking this address to that network. Same thing should happen on the 101 host. So if we ping 192.168.1.100, destination host unreachable. If we ping 4.100, we should get a response. And we did. And then on the 102, we should get a response from both pinging the 1.100 host, which we do, and also on the 4.100 host. And as you can see, that shows that our ACL is properly configured, and all three of these can communicate successfully with this PC, but not with this 1.100 PC. So when setting up an ACL, you need to be very careful about the order in which you input the commands, because when running, traffic will be checked for each condition from the first one down to the most recent. And if any condition is configured in the wrong order, some unwanted traffic might slip through your defenses, and obviously that's not what you need if you're trying to set up a strong security system. So as a rule of thumb, it's best to start with more specific statements and work your way down to more general ones. So to show an example, we're going to go into the um, R0 routers CLI, the command line, and we're going to input a show run command so we can see what commands the router is looking through and which conditions it's scanning for. So here you can see on this access list 99, the 99 is the number of the access list, and for a standard ACL, you're typically going to want to have a number between 1 and 99 to have it function properly. So the way that we have it set up here is with our specific statements, we have it to deny specifically this host 192.168.2.100 and to deny the host 192.168.2.101, which are these two. And then finally, we have a permit any command, which means that any host that is not this one and not this one will be let into the network. And if we don't have this permit any here, there is an implicit deny all here at the end of the access list. It's never shown, but if you don't have any specific command that tells your router to let in other traffic, it will deny all traffic, even if you've only told it to deny these two. So this is why it's really important to specify which traffic you actually want coming into your network, because if you mess this up, you're just going to have a non-functioning network that can't communicate with anything. And that is not what you're going to want. So here, if we say, for example, that we had set up the permit any first, then because it's scanning from top to bottom, even though we have these deny host commands in here, if the permit any is first, all the traffic is going to go in because when the router gets the traffic, it sees that first line, it says permit any, and it's going to let all the traffic in. So this is why it is crucial to make sure that your ACL is set up in the proper way, because otherwise your security system is not going to function and you're not going to have a good time. All right, thank you for watching. That's my presentation on access control lists.